You don't need that much time. I don't know. Half my time was procrastinating. Yeah. I get rid of my PTS there. But the thing is that I'm probably gonna spend like 10 minutes on it. Yeah, so I can just like remember. So I don't think I take it seriously. So, like, I think it might be. I was really like, I really wanted to just submit like the prompt for like the AC and SBI. Yeah, I wanted to do that. Honestly, I might. Just like describe something that you enjoy or something. Yeah. Because whatever it's saying, yeah, I'll just paste the random answer and there you go.
I think that's a guarantee.
It's already
Good morning. Good morning. Oh, let me tell you, if I can be absolutely honest. I'm not sure. Probably you guys were terribly excited when your alarm. You didn't even need your alarm this morning because you were so excited to return back to school. But definitely was getting to see you guys today. So thank you for the gifts that you are. Because man, yeah, that was a little hard. And I kept telling myself, like, I need to, like, I don't know, wake up a little earlier and earlier and earlier every day. Oh, so this morning, a little rough. I hope that you just enjoyed an amazing Christmas break and great New Year's with your family. Maya shared that she traveled. Do you mind sharing again?
I went to Arizona and New Mexico.
Absolutely amazing. Anybody else not mind sharing if they traveled? Yeah, that gray sky here in southwestern PA, holy smokes. Warmer temperatures, I didn't mind. Sorry, those of you that really were hoping for a white Christmas. But wonderful to be with you guys today. All right, so the name of the game for our time. When I was just trying to find some graphics to start out today, man, I really like that one. If I could share, I know sometimes maybe as a family, you set goals for the new year or talk about New Year's resolutions. Not sure if you guys do that at all. Usually we don't in the Gerhardt family, but I just thought we're kind of all sitting around and thought, okay, guys, is there like a word that is going to be motivating for you this year? And so my daughter, who is so funny, was coming up with all these things to make us laugh. My oldest, who's going to graduate from college and start his like first for real job, was coming up with things. And I love what my 17-year-old said. He just said, Mom, this is just my goal for the year. Better. Just better. So that really applies to all of us in some way, shape, or form, huh? So I don't know. That kind of picture just encapsulated that, at least for me. Not that we're going to do better things. Not that I want better students, because I already have them. All right. We are going to warm up with some questions here, but I want to make sure that I share with us where we're heading. All right. There is in Canvas posted for you. So I was waiting until I got at least the entire month of January ironed out as far as tentative calendar. So this week back, today we're going to get the background for spectroscopy, which will be our lab adventure through Thursday. We have a couple topics on the solution chapter. Otherwise, we have already learned so much solutions. So just a couple things. And I thought we would tackle that kind of just assessing our understanding in kind of a team effort like we did chapter 10. So lab work this week. And then we're going to just sprinkle in a couple purposeful topics, especially how about making solutions. You guys will actually physically make some solutions using volumetric glassware and so on. And so we will have a lab due because next Thursday is the end of our quarter. And then a team kind of question effort like we did with chapter 10. That will be the next 2 weeks. And then you guys get to enjoy a 4-day weekend. Woo! So yeah, we're back for 5 days, but then the next 2 weeks are 4-day weeks for you guys. And then, oh my gosh, if I really had to say what my favorite chapter was, oh, so hard because chemistry is so fantastic. But man, rates is definitely up there if I had to really pick one. Oh, can't wait for kinetics for us. So just wonderful territory come this winter. All right, so today we want to entertain, okay, well, what is spectrophotometry? So to start that, the questions that I have on the front of this packet, these are going to be our warm-up questions. If you can give a minute of your own thought, and if you want to rely on a neighbor, but couldn't we give ourselves, how about 4 minutes? So in each of these blocks, there's information shared about an element. Can we use that information to narrow down or identify the specific element? Okay, go. We'll check in 4 minutes. You can pop around, go in any order. If you need calculators, there are tables, you know where to get them. We want a couple more minutes? Okay. Um, bless you. All right. So if I could rudely interrupt you. So who can go ahead and answer one of these? And if it's okay with you, I'm going to go ahead and call this A, B, C, D, E, just for sake of, discussion. Jeremy, take it away.
For B, I got copper.
Tell me, well, do we want to just get answers first? All right. So for B, you're saying copper. Go ahead, Ava.
D is aluminum.
Anybody else? Any other takers? Katie?
A is aluminum.
Any other? Oh, incredible students. I know you couldn't wait to come back to chem. Go ahead, Jackson.
E might be hydrogen.
Victor?
I got copper for C and also for carbon. So.
It's okay. All right. Well, let's see. Definitely. And let's see other award winners. How did you come up with rubidium for A?
Because the most common average atomic mass is 85. Like 0.72 times 85 plus the 0.28 times 87.
What do each of these represent, Katie? What is this a graph of?
The isotopes.
The isotopes. And we would definitely predict that a sample of this element was injected into a mass spectrophotometer. We don't have to remember that. But then the different samples are accelerated, and then we detect the mass of each and then the relative amount of each of our isotopes. So this allows us to say, oh, there's two isotopes, but we encounter this form a little more often. We could say, okay, so it's not going to be a, a true average of 50-50. We are definitely going to have a weighted average closer than the 85. And whenever we look at the periodic table, dun, 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 rubidium is it. Excellent. Excellent. We don't have many bar graphs in chem. So this is pretty much, I don't know if we really call these, of course, a bar graph. But so that's pretty much just the mass spec. Mass spec results, which are going to allow us to determine the weighted average and the number of isotopes. Excellent. Oh, fantastic. How are we feeling about, Victor, you said D, right? Is aluminum, or wait, no, Victor, I'm so sorry. Who gave us D? Ava. So is Ava correct? Explain.
I just looked at each orbital, so the last valence one is 3p1, which would be aluminum.
If you could hold on a second, because I believe I overheard Mr. Luke say what this graph represents. I think I heard you say a phrase that has two words, begins with an I and then an E. Did I hear you say that? I think I did.
I'm not sure.
You're just being so humble.
I think I did.
I don't know. Again, being humble. So what phrase am I after? I heard someone say it. Porter?
Ionization energy?
Oh! Am I giving Luke credit for you?
I don't think so. I just knew what you were referencing.
Well, you're a power couple, so we're giving you both a credit. All right. Ionization energy. This is relative number of electrons and the energy that we had to invest to eject them. What I would do first is look, this is 1,000, 100, 10, so it's high to low. These are going to be our closest to the nucleus. Those require the greatest amount of effort. And we definitely know this is going to be ground state unless otherwise indicated. So 1s2, 2s2, 2p6, 3s2, 3p1. Excellent, Ava. You're welcome. All right. So good there. And this would be PES, positron emission spectrum. We don't have to remember that, but this is how we get electron config, which is showing us ionization energy. Fantastic, fantastic, fantastic. Okay, so we're good with A, we're good with D. Let's get to C. Victor, that's what you said, right?
Yeah.
Okay. How did you narrow down carbon?
So I just looked at it because there was a huge spike in ionization energy for the fifth level. And so I thought it was either carbon or silicon, but I couldn't really tell between the two, so I just did carbon.
All right. So we know ionization energy that must be invested to remove electrons. These are always going to be positive values. Yeah. And as we're removing consecutive ones, remember, as you remove electrons, there's less electron repulsion. And they're going to be then closer to the nucleus, so they require more energy to eject. So we expect these to increase. But where we get our huge jump, we're probably going from valence to then inner core. We're probably going down a whole energy level. And so we would anticipate that this element has 4 valence electrons. Okay, so that gives us carbon's group. Can we tell from there? Can we tell if it's carbon or silicon, or just narrow it down? All we can tell is it's a group 14 element. That's it. But you narrowed it down, sir. Very good. Very good, very good. So that's as far as we could go. We need more information. Now, if it said it's a period 2 element, well, then we know it's carbon. A period 3, then we know it's silicon. But we needed an extra piece of information, but it's definitely group 14. All right. Go ahead, sir.
I changed my answer.
Okay. So probably why would copper like be uncomfortable? No offense.
Because
And plus MgCu2.
Yeah.
And that is okay for us to say, like, does that just like feel right? And if that just, usually we have metals with non-metals. I mean, could we? But remember too, when we combine most metals, we get mixtures, not often compounds. So that kind of like, just feels uncomfortable. Okay, so you said you revisited this.
yes, I got fluorine. So first I got I used the percent mass of X, like I subtracted that by 100 or 100 by that. So I got the percent mass of magnesium,
Okay.
and then I did like this, I forget what it's called, like the cross multiplier or whatever, to get the total mass, and then I used the total mass to get the
Wait, hang on 1 second. So you subtracted from 100
Yeah.
to get, but that's a percent. So 39% magnesium or what?
39%. Yeah, 39% of magnesium X2 is magnesium.
Okay.
So then so then I got the total mass of all of it together, which was like 62.3 about.
Wait, where'd that come from?
I don't know how to explain this equation I did, but like I don't know, I just got the answer.
Which I understand totally. We all understand because we often get there. We're like, well, we did it, but it's so hard to put into words.
Yeah.
So please, we're just recognizing that, yeah, we feel like that a lot of the time. Well, did you move forward thinking it was MgF2?
Now, so okay, can I just write it on the board?
Oh my gosh, yes.
Alrighty.
Step back just for a second.
So okay, that's not the dx. This is just x as a variable.
Understood. So, wait, that's 24.3. And what is that?
That's the atomic mass of.
Exactly. Do you mind if I just add? So this is how many grams of magnesium? And so is this mole of magnesium?
No, that's the total mass
Of the compound.
of the compound.
So this is grams per mole of magnesium and then grams per mole of compound.
Yeah.
Okay, of MgX2.
Yeah.
Yeah. Okay. And then
So that gets then x equals 62.3, and then that's like the total mass of the compound.
yeah,
And then
that's the molar mass.
yeah. And I subtracted the molar mass of magnesium.
So this is very similar to the gravimetric kind of analysis.
Yeah. So then I got 38. Yeah, 38 basically.
Okay.
And then
And that represents 2 moles
Yeah.
of X.
And then I divided that by 2, so I got 19.
So James, close. Yeah, because you said chlorine, correct? Or was I wrong on that, James?
I didn't say it.
Oh, I think I heard that. It just seemed right. So you guessed chlorine. Shoot, so close.
Oh, okay.
Yeah. Is that explanation okay? Bravo, sir. Thank you for correcting away from copper. Very good. Oh, let's see. Oh gosh, you know my hand-eye coordination. Very sorry. Oh my gosh, I'm so sorry. I am so sorry. Okay, so that leaves us here. Okay. What is this a graph of? Absorbance versus wavelength. Wait, wavelength? What kinds of things do we overwhelmingly associate with wavelength? Things that travel in waves. Remember, there's all different kinds of light. Now, of course, we can say matter moves with waves. Electron definitely moves in waves. We can measure that, et cetera, et cetera. But this range, okay, this is the visible spectrum. The visible spectrum. Okay, Maya, I know that you know. All right, we have gamma rays all the way to microwaves and radio waves. And then kind of smack dab in the middle is visible. Now, is gamma high radiation or low, high energy or low energy? Yeah. And then this would be low energy. Okay, now, how about wavelength? If it is high energy, does it have long wavelength, short wavelength?
Short.
Yep. And then what about its frequency?
High frequency.
Yep. Okay, so visible, if we're going from high energy, the highest energy is violet. It's Roy G BV backwards. Yeah? Okay. How did you know, Jackson, what wavelength, what color 600 nanometers was?
I just did.
Ah, that's pretty extraordinary. Absolutely extraordinary. Could I ask us to turn to what is indicated as page 99? Okay, we're just going to have to use our imaginations. So this is the 3rd page in our packet. Okay. So here I have a color wheel, and sorry that, of course, it's not in color. Okay, so here is the beginning, 400 nanometers, and from about 400 to 430 is purple, 430 to 480 in general, blue, and so on and so on. So you said 600 was...
I said red. It was around the red.
I know, not bad. And again, there's like, you know, how in our humanness, we're saying there's orange, but we know that it becomes like orangish red and then reddish orange. So this is like in general. And so, yeah, 600 would be kind of like, you know, an orange color. Okay. So what can we say about our substance, and can we specify a certain element? Okay, we're going to come back to this because our adventure is spectrophotometry. Okay, I hope this will make you laugh. Oh, that's in the way. A little bit funny, not so funny. They hate it when you carry the test tubes that way. Oh, not funny. See over his ear? Like your pencil that you don't want to lose to put your test. No. Now we're going to be working not only with test tubes, but a special piece of equipment called a cuvette. All right, what I want to do, ladies and gentlemen, is lay the foundation of what is spectrophotometry. So in all sciences, there's like certain go-to lab methods. Before Christmas break, we looked at gravimetric analysis. Well, spectroscopy is another go-to method, where like dissection in biology or electrophoresis. Do you guys do that in? Or cell cultures. What else is, I don't know, what's like a physics lab technique? Like we're applying lenses, I don't know. Anyway, like it's a technique. All right, so spectrophotometry has different areas in chemistry. We reminded ourselves of mass spec and PES. What we're going to do this week is called UV vis spectrophotometry. Okay, so spectrophotometry is the investigation of how matter interacts with light. The investigation of how matter interacts with light. All right, have you gotten an X-ray ever? I'm sure we have in dental exams at least. That is investigating how the structure of your teeth interacts with X-rays. We could even say when we use a microwave, if we're measuring, then we're investigating the interaction of your piece of lasagna or pizza or water with microwaves. So we are looking at, okay, how does matter interact with light? And there's all different types of spectroscopy. And you apply the type per what you're trying to answer. I had to laugh because, I don't know, when my kids were young, we would set a time on Christmas morning that they were allowed to come downstairs to like see their gifts. And funny, when they were so young, it was 6. And then it went to like 7 a.m. And of course, as parents are like, oh yeah, okay, we're getting like closer to like 7:30. That seems reasonable because they were so excited, so excited. And this year, my kids were like, 10? How about 10? But then my boy said, oh yeah, Mom, because we're going to get up and watch the launching of the new satellite. Anyway, the new NASA satellite that's going to, well, they didn't. But I was like, oh, look, my sons. They're looking, anyway, I didn't know if anyone else knew of that or anyway, it's a new telescope that is going to take advanced images of different parts of our galaxy using infrared spectroscopy, heat. Okay, we this week are going to be looking at only this little realm, a little bit into ultraviolet. So to detect damage in very high density substances, we can use X-rays. We'll talk about more to come. All right, spectroscopy answers one of two things. What is there and how much is there? What is there and how much is there? Okay. What we do is we take our sample, we expose it to the radiation, and then see what happens. All right. There is, let's see. Oh, let me go back to that. Oh, of course, it's not going to let me. Hold on one second. I'm so sorry. Oh, I'm sorry that I didn't have this all ready to go. All right. So what we have here, I know it seems just so simplistic and elementary, and I'm so sorry to insult you. I hope you don't feel insulted. What we have in the middle of the screen are just samplings of different molecules. And then we have a choice to shine, if you will, different types of radiation at it, and then to tell what does it do. All right. So, Adam, you choose. What substance? They already have carbon monoxide chosen, but you choose. Do you want to stay with carbon monoxide? All right. So, let's just see what carbon monoxide does, and you choose, sir. So, we could shine microwave radiation, heat, visible, or ultraviolet. What do you want to do? All right. Now, in our realm, UV is above IR and then microwaves, of course. Okay, so you're saying right off the bat, let's just nail it with as high of energy as we can. What do you predict might happen? Now, carbon monoxide, and you see, I know it's really hard for those of you in back to see there's a triple bond between the carbon and the oxygen. Could we break that triple bond or break one of the connections and make it a double bond per se? And so what this allows us to do is just, nothing. Well, let's try visible. Nothing. How about infrared? Oh. I like the sound effects, of course. Okay, so do you see? Well, we're just causing it to vibrate. Now, how do we know that it's doing that? Because we can't see and we can't hear it. Because did you see they're showing that something is released? All right, let's see microwaves. That causes rotation. All right, so not all substances respond to all different types of light. So whatever we're trying to answer, we just can't always depend on ultraviolet or always visible. So there's wisdom in what have you chosen to do what. Water. What if we shine, and let's just go ahead and say, because it's a green button, that's green light, or maybe it could be red, or it could be purple. Well, if we shine purple light on a water molecule, what will the water molecule do with purple? What kinds of things interact with colored light? What kinds of things? I'm so afraid that one day my husband or my children will ask, what is my favorite Christmas present? Because to be honest, it's when I was a little kid. I love, especially the homemade Christmas presents my children give me. But if I have to be honest, my very, very favorite Christmas present, true story, was a Fisher-Price microscope. Because when everybody else was playing like with their sheets and everything and their Afghans and making forts, and I grew up with all boys, so they were like all Army, and my fort was my lab. I always knew I wanted to go into science. So man, when I got that Fisher-Price microscope, I like carried it around with me everywhere. And what could I put underneath? So I just thought it was so neat to look at a strand of my hair under the microscope. I remember my dad and mom were like moving a piece of furniture, and my dad backed up into a nail that was sticking out of the wall, and he was bleeding, and I was so excited I could get a sample of his blood. So I remember it was about a week later, and my tooth fell out. I was like, oh, I can look at my. When I put it there, I saw nothing. Black. So, under a microscope, you're using magnification. You get your slide all ready. If you imagine me as this little, peanut putting my tooth. And it had battery power for the light. So I'm using visible light to help. So when you guys prepare microscope slides, don't even use those little things. Sorry, Mr. Antilli would be so disappointed in me. What do you call those little pieces that you put on your sample and it like squishes it all down? What do you call those? You have the slide and then you have the little inserted thing. And don't you just drop it on? That's why I'm making that sound effect. Yeah, I know. Does it have a special name? See? And of course that like protects it, but what kind of things interact with visible light? We need two criteria. So why our water is going to do a whole lot of nothing. If you shine a flashlight, we don't hear nothing. We switch out to the NO2. All right. What color is carbon monoxide? Clear. What color is water? NO2 is brown. Okay. Nothing assigned for tomorrow. Tomorrow we'll dig in. All right. We'll get into our lab work tomorrow. So Jackson, all that we can tell is what color it's absorbing. We can predict what color it is. That would help narrow down, but not.
Good. I know, like, I just had a big piece of red. It seems like it was bad.
So very good, very good, very good.
I don't know. They either slept in or just slept in.